What is the strangest thing we've ever found on the moon? Not aliens, not a secret military base, but something far more unsettling, something that shouldn't be there at all. Imagine this, the most barren, lifeless rock in our entire night sky suddenly whispering that it might hold water. Yes, water. That thing we spill on the kitchen floor, the thing we bottle and sell for $2 at the airport, the thing that makes up most of our own bodies. Water, sitting quietly on a world that for decades was described in every textbook as bone dry, sterile and inhospitable. It sounds impossible, and for half a century humanity acted as if it was. After the Apollo missions ended in the 1970s, our footsteps vanished from that pale dust. The silence of the moon stretched on, broken only by the occasional robotic visitor, tiny metal scouts hurled across space to map, crash, or dig at its surface. And yet, the biggest secret of the moon wasn't revealed by a heroic astronaut planting a flag under a blazing spotlight. It slipped into our world quietly, like an overlooked footnote. A single soil sample, smaller than a baseball, smuggled into human history not with fanfare, but with yawns. Because in 1976, the Soviet Union's Lunar 24 mission drilled into the lunar surface, just 2 meters deep, and pulled up a pinch of soil. When scientists got it back to Earth and began poking at it, they saw something that made no sense. Traces. Microscopic, stubborn traces. Of water. At first glance, it was the kind of discovery that should have set the world on fire. A cosmic plot twist that rewrites our understanding of the moon. But instead, silence. Shrugs. Eyebrows raised and quickly lowered. Because in the neat, confident pages of every planetary science textbook at the time, one phrase was written in stone: the moon is dry. So if the data said otherwise, well, that data must be wrong. Contamination, they argued. Maybe moisture from Earth got into the sample. Maybe the lander leaked. Maybe the lab equipment wasn't clean. Water on the moon was dismissed as a mistake, a ghost in the machine, and the file was quietly closed. But history has a way of making fools out of certainty. And this little footnote, forgotten in the dust, would return decades later to haunt science, and to remind us that sometimes the greatest discoveries are the ones we ignore. After Lunar 24 slipped back into the archives, the moon became something like an old family photo album. Everyone remembered it fondly, but no one really opened it anymore. The Apollo era had ended with a mixture of triumph and exhaustion. 12 men had walked on the lunar surface, gathered rocks, planted flags, and returned with stories of grey dust and infinite silence. Then the curtain fell. The budgets shrank. Humanity looked elsewhere. For half a century the moon remained untouched by human boots. No new footprints pressed into its ancient soil. No new voices bounced off its crater walls. Only a handful of machines were sent its way, metal emissaries on one-way trips. Some circled in orbit, clicking pictures. Others tried to land, sometimes succeeding, sometimes dying in silence upon impact. A few were deliberately hurled into the surface, just to see what would happen. The moon was no longer a stage for explorers. It had become a laboratory pet, prodded and scanned from afar, and yet it stayed oddly uncooperative. For all our probes and calculations, the moon never gave us simple answers. Its rocks behaved strangely under heat. Its soil carried electrical quirks we barely understood. Even its ability to store and release warmth baffled scientists. The more we studied, the more questions multiplied. This is the peculiar cruelty of science. The closer you look, the less you feel you know. Every answer cracks open into a new question, like Russian nesting dolls with no end. So when those first hints of water appeared in Apollo samples and Soviet drills, scientists had the perfect excuse to ignore them. It doesn't fit. And in science, if something doesn't fit neatly, it's often set aside until later. Only later never came. For decades, the world was content to parrot the same refrain. The moon is dry, lifeless, sterile. Nothing grows there. Nothing flows there. The moon is a monument, not a mystery. But reality is stubborn. And reality doesn't care what textbooks say. In the dusty corners of laboratories, in mislabeled jars of lunar soil, something far greater was waiting. The story wouldn't stay buried forever. The year was 1976. While the Apollo program had already taken its last bow, the Soviets still had one card left to play. Their robotic probe, Lunar 24, touched down on the moon for a quiet mission. No television broadcasts, no cheering crowds, just a machine drilling into lunar dust, then scooping up a small precious sample from about 2 meters beneath the surface. 2 meters doesn't sound like much, but on the moon that's deep enough to hide secrets untouched by sunlight for billions of years. The prize, a tiny core of soil weighing about 170 grams. To put that in perspective, about as heavy as a baseball. A child could hold the moon in their hand. When this little cylinder of dust arrived back on Earth, Soviet scientists did the usual routine: heat it, analyze it, break it down into graphs and numbers, and then something impossible appeared. Embedded in that grey powder there were traces of water. Not much, about 0.1% by weight, barely anything at all. But the deeper they looked, the more water they found. Pause for a moment. Think about that. The moon, our dry, lifeless neighbour, wasn't so dry after all. This should have been a thunderclap in planetary science, a discovery to rewrite textbooks overnight. Imagine the headlines, "The moon holds water," but instead, nothing. The water was quickly written off as an error. Maybe the soil was contaminated during transit. Maybe Earth's atmosphere left fingerprints on the sample. Maybe the lander itself leaked. After all, the logic went, the moon is dry, it must be dry, everyone knows it's dry. And so, the anomaly was buried under skepticism. Reports were filed away, the world shrugged, and life went on. But in hindsight, that little core sample was a warning shot, a clue that the moon had more to tell us. A secret lodged not in oceans or rivers, but in whispers hidden in its dust. Sometimes the universe doesn't lie to us. Sometimes we just refuse to listen. Long before Lunar 24 drilled its little hole, the Americans had already brought home hundreds of kilograms of lunar soil. Apollo astronauts bent over in bulky suits, scooping grey dust into bags, stuffing rocks into containers, proudly returning them to Earth like miners hauling treasure from another world. Those samples were studied, catalogued and displayed in laboratories across the US, and buried in the data, quiet, almost invisible, were tiny signals. Faint traces of hydrogen, hints of moisture. Not puddles, not streams, just the ghost of water. But just like the Soviets later, NASA scientists waved it away. Contamination, they said. Maybe the astronauts' tools weren't perfectly clean. Maybe the soil soaked up a little humidity once it was opened on Earth. After all, textbooks told them in bold letters, the moon is dry. So they filed it under noise, irrelevant, a smudge on the lens. And yet, looking back, the irony is delicious. Both superpowers, locked in their cosmic rivalry, each desperate to prove they were the superior explorers, had stumbled across the same quiet truth. Both had touched the same forbidden thread. And both had snipped it out of the record. Because to admit the moon had water wasn't just to rewrite a line in a textbook, it was to admit we didn't fully understand the very world we had just conquered. And that was something neither side seemed eager to face, so the clue was left to rot in the margins of lab reports. Dusty samples sat in storage. Scientists moved on to shinier problems, and humanity, so proud of its leap into space, walked right past one of the most important discoveries hiding in plain sight. The moon had whispered, and we covered our ears. But whispers have a way of returning, especially when the silence grows too heavy. If you were to stand at the edge of the moon's poles, say, peering into a vast crater at the southern tip, you would see something that feels unnatural. Not because there's anything there, but because there's absolutely nothing at all. No sunlight, no warmth, not even the faintest glimmer of reflection. Just darkness. A darkness that hasn't moved in billions of years. These are the permanent shadow regions, the moon's eternal blind spots. They exist because the moon barely tilts, just 1.5 degrees off-center. Compare that to Earth's dramatic 23.5 degree on tilt, which gives us seasons, summers and winters. The moon doesn't bother with such flare. It stands almost perfectly upright. So when the sun shines at the lunar poles, its rays skim the surface at a razor-thin angle. Craters, deep and jagged, act like bowls. Sunlight may paint their rims in dazzling white, but the interiors remain untouched. For billions of years, these hollows have never seen morning, never seen evening. They are places where time itself feels frozen and cold. Calling them cold is like calling a black hole dim. Temperatures there plunge below 240 Derensem, colder than Pluto, colder than anything else in the inner solar system. These craters are the deepest freezers nature ever built. Now imagine, what if a comet, loaded with ice, slammed into the moon ages ago? What if water molecules sprayed into these pits, then instantly froze, locked away forever? They wouldn't evaporate, they wouldn't escape, they'd simply wait. This idea electrified scientists in the 1990s. Suddenly the moon wasn't just a dead rock, it might be a vault of cosmic water, a treasure chest hidden in the shadows. And with that thought, human curiosity began to burn again, because the moon, long considered a dry tomb, was starting to look like something far more useful, a reservoir, a fuel depot, a key to our future in space. Once the idea of those eternal craters spread, scientists began whispering a tantalizing theory. What if water really had been delivered there long ago by visitors from deep space? Not little green men. No, something far less glamorous and far more common. Comets, asteroids, cosmic delivery trucks. See, comets are basically dirty snowballs, giant ice cubes laced with rock and dust. Every time one barrels through the solar system, it leaves a shimmering tail of gas and frozen particles behind it. Asteroids, too, can carry minerals that hide water deep inside. For billions of years, both comets and asteroids have smashed into the moon like hailstones against a tin roof. On Earth, much of that ancient water may have boiled away, recycled, or been absorbed into oceans and rivers. But on the moon, different story. No atmosphere, no air pressure, no protective blanket. When ice splattered across its surface, most of it would have evaporated instantly under the scorching sun, except in those permanent shadow regions, in those black pits where sunlight never reaches, temperatures plummet so low that water vapor freezes instantly. Trillions of molecules could drift down into those shadows and stay there forever, trapped like fossils in a cosmic freezer. The logic was clean, elegant, even exciting. It suggested the moon wasn't just an old relic, it was a kind of cosmic pantry, a place where water could be stored for billions of years, preserved by nothing more than geometry and cold. And water, as every astronaut and engineer knows, is not just for drinking. It's oxygen to breathe, it's hydrogen for fuel, it's survival. If this theory held true, then those black craters weren't just shadows, they were treasure vaults, future gas stations for humanity's leap into deep space. But first, we had to prove it. And proving it meant sending our machines back to the moon, not to plant flags, but to start digging. The first step in any treasure hunt isn't grabbing a shovel, it's drawing the map. And in the 1990s, NASA decided it was time to redraw the moon. So in 1994, they launched Clementine, a small spacecraft with a poetic name but a very practical mission, to map the moon in unprecedented detail. Think of it as Google Maps for a place with no Wi-Fi, no roads, and no restaurants, just endless craters. Clementine wasn't sent to hunt water. That wasn't even on its to-do list. Its job was to take images, scan the terrain, and build a digital atlas. But as it circled and scanned, it revealed something more valuable than pictures, confirmation that those permanent shadow craters at the poles were real, vast, and, if the theories were right, potentially full of frozen secrets. The mission didn't carry the right instruments to peek inside those shadows. It could only tell us, here they are, big, deep, dark. Like a cartographer from centuries past, sketching coastlines without knowing what monsters lived in the seas beyond. But Clementine lit the spark. It showed scientists exactly where to look. And suddenly the moon wasn't just a dead rock hanging above us. It had coordinates, targets, X's on the map where treasure might lie buried in ice. For the first time since Apollo, the world began to lean forward again, squinting at the moon, wondering, if water is there, how much, and how hard will it be to get? The old dusty photograph of the moon had been updated, and now humanity's eyes were fixed firmly on its cold, dark corners. 4 years after Clementine traced the moon's scarred face, NASA decided to stop playing tourist and start asking harder questions. In 1998, they launched the Lunar Prospector, a probe with one mission written across its blueprints: find water. Unlike Clementine, Prospector wasn't there to admire the scenery. It carried instruments designed to sniff out the moon's invisible fingerprints. Among them, a neutron spectrometer, a tool that can detect hydrogen hidden beneath the lunar soil. Why hydrogen? Because hydrogen is half of the recipe for water. Where hydrogen clusters, oxygen might be waiting nearby, and together they spell H2O. As Prospector skimmed the moon in low orbit, it started pinging signals back to Earth. And those signals lit up like neon signs at the lunar poles. Hydrogen, lots of it. Especially in the very regions of permanent shadow, the deep, black craters Clementine had mapped earlier. Scientists nearly burst with excitement. If those signals truly pointed to frozen water, then the reserves weren't small. They might measure in the tens of millions of tons. Imagine, not just a puddle, but enough ice to fuel generations of spacefarers. Enough to turn the moon from a barren rock into a cosmic gas station. But here's the rub. Hydrogen alone doesn't prove anything. It could mean ice, yes. But it could also mean hydrogen atoms trapped inside minerals, bound tightly in crystal cages, with no drinkable water in sight. Prospector had given us a clue, but not a confession. The moon was teasing us, showing just enough to drive us mad, refusing to reveal the whole picture. So the whispers grew louder. Water is there. Water must be there. But where is the proof? Hydrogen is a trickster. It's the universe's most common element, and on the moon it shows up everywhere, just never in the way we'd like. The Lunar Prospector's instruments had revealed hydrogen clustered at the poles, yes. But here's the catch. Hydrogen doesn't automatically mean water. Think of it like walking into a kitchen, smelling garlic and declaring, "Ah, there must be pizza here." Maybe. Or maybe someone just dropped a clove on the floor. The scent is real, but it doesn't tell you the whole story. On the moon, hydrogen could be part of ice. That was the dream. But it could just as easily be locked inside minerals, like a stubborn tenant refusing to leave. Or it could be the residue of solar wind particles that bombarded the surface for billions of years, embedding hydrogen atoms in the soil without ever creating a single drop of drinkable water. In other words, the signals told us something unusual was there, but not what. It was like being handed a locked box, shaking it, hearing something rattle but having no key to look inside. This was maddening for scientists, because if those signals truly meant ice, the implications were staggering. Whole industries of future space travel could rely on it, but if they were wrong, then the moon was still just a dry, dusty rock with a sense of humour. And the moon, it seemed, wasn't in the mood to clarify. So the whispers continued. Hints without proof, shadows without light. The moon had raised the stakes and left us dangling in the dark. At some point, the scientists grew tired of being teased. The moon had been dangling clues, hydrogen here, whispers of ice there, but never offering proof. So they came up with a plan so blunt it almost sounded childish. If we can't see the water, let's smash the moon and make it spray in our face. Yes, really. The logic was simple. If ice was hiding in those permanently shadowed craters, sunlight couldn't touch it, telescopes couldn't spot it, and orbiters couldn't confirm it. But what if you hurled something heavy at the crater floor, something big enough to dig up the dirt and fling it into the sunlight? If water was there, the debris would carry it up where instruments could finally detect it. It was science by sledgehammer. Crude. Desperate. Brilliant. The first attempt came in 1999 when the Lunar Prospector, after finishing its mission, was deliberately slammed into a crater near the South Pole. Scientists back on Earth waited like detectives staring at a crime scene, hoping for a puff of water vapour, a glimmer of ice crystals, anything. But the result was silence. No splash. No definitive signal. Just a dry crater and a dry report. Some blamed the impact angle. Maybe the probe hit wrong. Others said the instruments weren't sensitive enough. A few suspected there simply wasn't any ice there at all. It was like kicking down the door of a treasure vault, only to find bare stone walls. Still, the idea stuck. Smashing the moon wasn't just reckless curiosity. It was one of the only ways to solve a mystery buried in eternal darkness. If the first punch didn't land, humanity was ready to wind up again for another. Because if the moon was hiding water, we weren't leaving without an answer. A decade after Lunar Prospector's disappointing belly flop, NASA decided to try again. This time with more precision, more instruments, and a much bigger punch. The mission was called El-Quiros, short for Lunar Crater Observation and Sensing Satellite. But honestly, it could have just been called Operation Cannonball, because the plan was as straightforward as it was brutal. Hurl a giant piece of metal at the moon, then watch what comes out of the explosion. Here's how it worked. El-Cross launched in 2009 attached to a Centaur rocket. Once they arrived at the moon, the Centaur itself became the weapon. NASA pointed it at a crater near the South Pole called Cabeus, a deep pit of eternal shadow, one of the coldest places in the solar system. First, the rocket body, and 2.3-ton hunk of empty metal, was sent hurtling downward at over 9,000 kilometers per hour. Imagine dropping a skyscraper-sized hammer into an icy cave. The impact kicked up a massive plume of debris, dust, and, hopefully, whatever secrets the crater had been hoarding for billions of years. Trailing right behind was El-Cross itself, the spacecraft's main body. It flew straight through the plume, like a detective walking into a crime scene as the dust was still settling. Its instruments sniffed, scanned, measured, and just minutes later, El-Cross 2 slammed into the crater, dying in the same darkness it was sent to probe. And the results? For the first time in human history, we had direct confirmation of water on the moon. The plume carried water vapor, ice crystals, and even traces of other volatile compounds like methane and ammonia. It wasn't a whisper. It wasn't a maybe. It was proof. The moon had water. For a moment, the world erupted in celebration. Headlines shouted it. NASA scientists popped champagne. A decades-long mystery had finally cracked open. But as always with the moon, every answer only gave birth to new questions. For a few glorious days in 2009, it felt like the moon had finally confessed. The plume from Cabeus crater carried not just dust, but unmistakable signatures of water. For the first time, science could point and say with certainty, it's there. NASA's press rooms buzzed. Reporters wrote headlines about a wet moon. Engineers toasted with champagne. For once, the dusty satellite that had so often disappointed seemed to hand us a gift. But then the sober morning arrived, and with it, the inevitable question. How much water are we actually talking about? Was it an underground glacier, a frozen lake waiting to be tapped? Or was it more like powdered frost, thin films coating grains of soil, so diffuse that collecting it would be like wringing dew from desert sand? The instruments aboard El-Cross could confirm water's presence, but they couldn't draw a map of its abundance. Nor could they answer the more practical question that every space agency and future astronaut wanted to know. Can we actually use it? That single impact proved water existed, but it also underlined just how little we understood about its distribution. Was Cabeus special, a lucky jackpot? Or was this just the moon's version of a leaky faucet, drops here and there, never enough to quench a thirst? The celebration quickly cooled into cautious puzzlement. The moon had opened the door, then immediately slammed it in our face. In science, this is the cruel rhythm. One discovery sparks joy, the next moment multiplies the questions. The moon was wet, yes. But how wet? Where wet? And was wet even the right word? The champagne bottles were empty, but the headaches were just beginning. After El-Cross, scientists thought they'd finally crack the case. Water existed in those polar freezers, tucked away in darkness. Mystery solved, right? But the moon wasn't done playing tricks. Soon, orbital probes started detecting something bizarre. Water signals outside the shadows. Not in those eternal craters, but in regions kissed by sunlight. Places where, by all logic, water should not survive. And then came the stranger part. The signals didn't stay constant. They pulsed, they shifted. They appeared in the cool of morning and evening, and then faded away at midday. It was as if the moon was sweating. Imagine a stone sweating in the heat, its pores leaking moisture under the sun, then drying out by noon. only to glisten again at dusk. On Earth this makes sense. We have an atmosphere, clouds, rain, evaporation, condensation. Our water cycle is a glorious ballet choreographed by weather. But the moon? No air, no pressure, no clouds, no rain, nothing. Just rock and vacuum. So how could it possibly sweat? The discovery baffled everyone. It suggested the moon wasn't simply a passive freezer but an active system. Something was creating, moving, or at least redistributing water molecules on its sunlit surface. Something no textbook had ever predicted. For a celestial body long dismissed as dead and boring, the moon was suddenly behaving like a living thing, exhaling and inhaling in rhythm with the day. It wasn't just strange, it was revolutionary. Because if water existed beyond the poles, then maybe the entire lunar surface carried a thin, shifting veil of moisture. Not oceans, not rivers, but enough to matter. Enough to change the rules of the game. The moon wasn't just a silent rock. It was sweating under the cosmic spotlight. On Earth, the water cycle is simple enough that schoolchildren draw it in their notebooks. The sun heats the oceans, water evaporates, clouds form, rain falls, rivers flow. A neat circle of life, endlessly repeating. But on the moon, there are no oceans, no clouds, no rain. And yet, the data hinted at something disturbingly familiar. A cycle. The signals showed water molecules disappearing when the surface baked under the noonday sun, then reappearing as temperatures fell toward evening. Almost as if the moon were running a miniature water cycle of its own. Except, it shouldn't be possible. There's no air pressure to hold vapour. No blanket of atmosphere to trap molecules and guide them back down. Anything that lifts off the surface should simply escape into space, never to return. And yet, the evidence refused to vanish. Spectrometers on spacecraft kept seeing the same rhythm. Weak hydration signals at midday, stronger ones at dawn and dusk. A rise and fall that echoed the sun's daily sweep across the lunar soil. The best theories, maybe micrometeorites, endlessly pelting the surface, knock water loose during cooler hours, only for it to evaporate away when heat peaks. Or maybe solar wind particles, streams of charged hydrogen nuclei blown out from the sun, slam into oxygen-rich lunar minerals, chemically creating water molecules that briefly cling to the soil before slipping back into hiding. Whatever the mechanism, the implications were staggering. It meant the moon wasn't simply storing ancient water like a dusty museum vault. It was actively producing, losing, and regaining it, in its own alien rhythm. A place we thought of as utterly dead was showing signs of strange activity, as if it were alive in ways we'd never imagined. The moon wasn't just holding water, it was moving it, cycling it, whispering that the desert had more secrets than we ever gave it credit for. When scientists finally admitted the moon seemed to be sweating, the next question was obvious. Where on Earth, or rather, where in space, is this water coming from? Two main suspects emerged. Theory 1, the delivery service. Every single day, the moon is pummeled by micrometeorites, tiny fragments of rock and dust zipping through space at bullet speed. Some of these fragments carry water locked inside them, frozen since the dawn of the solar system. When they slam into the moon, they release that water like broken flasks shattering on stone. Some molecules escape into space, yes, but others burrow into the soil or settle in the shadows, adding to the moon's hidden reservoir. It's the cosmic equivalent of a drizzle. Drop by drop, over billions of years, enough moisture might have accumulated to matter. Theory 2, the in-house factory. The sun, far from being just a distant lamp, blasts the solar system with a constant stream of charged particles called the solar wind. These particles are mostly hydrogen nuclei, tiny, fast, and relentless. When they smash into the moon's surface, they collide with oxygen atoms bound in lunar minerals. Chemistry does the rest. Hydrogen plus oxygen equals H2O. New water molecules are literally forged on the spot, conjured out of rock and radiation. It's a bizarre, almost alchemical process. The moon, long thought sterile, acting like a factory floor, generating water molecule by molecule. Neither theory has been fully proven, and the truth may be a combination of both. Cosmic deliveries from above, plus chemistry at home. But whatever the source, one thing was becoming clear. The moon wasn't a hopeless desert. It was a place where water was not only stored, but possibly created anew. And for anyone dreaming of building a future on its dusty plains, that was the difference between an impossible outpost and a livable home. By the 2020s, the whispers about lunar water had grown too loud to ignore. It wasn't enough to peer from orbit or smash the moon with cannonballs. We needed boots, or at least wheels on the ground. And this time the stage belonged not to the US or Russia, but to India. In 2023, the Indian Space Research Organisation launched Chandrayaan-3, a mission with a bold destination, the moon's south pole. This was the holy grail of lunar exploration, the region scientists believed was most likely to hold concentrated stores of frozen water. Unlike past landers that had targeted the moon's equatorial plains, flat, sunny, predictable, Chandrayaan-3 set its sights on a far riskier neighbourhood, jagged terrain, eternal shadows, and temperatures colder than anything on Earth. But if water ice truly lay beneath the dust, this was the place to find it. The lander touched down safely, making India only the fourth nation to soft land on the moon. Out rolled the rover, Pragyan, its very name meaning wisdom. Equipped with spectrometers, lasers and X-ray tools, Pragyan was built to interrogate the soil, to sniff out hydrogen, and to finally answer the question, is the South Pole hiding ice? Around the world, scientists, journalists and dreamers leaned in closer. This wasn't just another robotic mission. It was the first real attempt to walk up to the moon's most mysterious shadows and demand answers. For India, it was a moment of pride. For humanity, it was a moment of suspense. If Pragyan confirmed water ice, it would rewrite the roadmap of space exploration. The rover's tiny wheels pressed into the soil, its lasers fired. Its detectors hummed. Humanity held its breath. And then the world waited for Pragyan's results like anxious parents outside an exam hall. Here it was, the rover rolling across the most promising landscape on the moon, probing soil that had never before met human eyes or instruments. If water ice truly lurked just beneath the surface, Pragyan was supposed to sniff it out. The rover scanned, it zapped the ground with lasers, it measured reflected light, checked for hydrogen, ran its data through spectrometers, and what did it find? Not water, no ice, just dust, rock, and more dust. For scientists, it was like being told the treasure map led not to gold, but to another empty cave. The South Pole, hailed as the likeliest vault of frozen reserves, offered nothing within Pragyan's reach. Was it all a mistake? Were decades of hydrogen signals just illusions, misinterpretations, overhyped hopes? Or was the problem more mundane? That water was there, but not where Pragyan could touch it. Maybe it was buried deeper, beyond the few centimetres the rover's small instruments could probe. Maybe it wasn't evenly spread, but locked in tiny patches, hidden like needles in a haystack. Still, the result was devastating. What was meant to be the moon's big reveal instead felt like the moon laughing at us again, a cosmic bait and switch. And just as the disappointment began to settle, nature delivered the final blow. The long lunar night was coming. 2 weeks of darkness and deadly cold. Pragyan, built to survive only in daylight, wasn't designed for such punishment. Time was running out. The rover hadn't found water, and soon it wouldn't be searching at all. As the sun dipped below the jagged horizon of the lunar South Pole, a slow death crept across Chandrayaan-3. Temperatures plummeted, first below freezing, then plunging past, 100 degrees, colder than Antarctica's cruelest nights. The lander and rover, powered by fragile solar panels, were never designed for this darkness. On Earth, engineers could only watch the signals weaken, then fade. Pragyan, the rover of wisdom, rolled no more. Its body froze where it stood, entombed forever in the moon's silence. The lander, Vikram, soon followed, succumbing to the chill. It was a heartbreak written into the mission from the start. A 14-day lifespan, nothing more. Pragyan had always been a mayfly, meant to shine briefly in lunar daylight, then fall silent when the eternal night arrived. And yet, even in its short life, it had delivered something unexpected. While the world focused on the absence of water, Pragyan quietly left us with another gift, data that hinted at something far stranger than ice. In its final days, the rover drilled its instruments into the soil, measuring how heat moved through the lunar surface. What it found would turn out to be just as important as water itself. Because sometimes, in science, disappointment isn't the end of the story. It's the opening act of a new mystery. Before the cold silenced it forever, Pragyan managed to lower a thermal probe into the lunar soil. The numbers it sent back looked almost absurd. At the surface, where sunlight blazed directly, the dust sizzled at more than plus 160°, hot enough to fry an egg, if eggs or frying pans existed on the moon. But just beneath that, the probe dug down a mere 8 centimetres, not even the length of a pencil, and suddenly the temperature collapsed to 10°, a drop of 70 degrees in less than the width of your hand. That finding was astonishing. It meant the lunar surface acted like a thick quilt, an insulating blanket of dust. Heat from the sun barely penetrated below the top few centimetres. Beneath that thin crust, the moon hid a cold underworld. Why did this matter? Because it explained why Pragyan hadn't sniffed out ice at the surface. If water existed, it could be hiding just centimetres deeper, protected by this insulating layer. A secret freezer buried not kilometres down, but just out of reach of our flimsy tools. Think about it. After decades of theories, after satellites and crashes and chemical analyses, the real problem might not be that the moon has no water, but that our shovels were too short. Pragyan's last gift was a clue, a whisper. Look deeper. Don't give up. I've shown you where to dig. Then the night fell. The instruments froze, and silence reclaimed the South Pole. Pragyan's thermal data left scientists staring at their screens with a mix of awe and frustration. The moon had all but confessed. Yes, something could be hiding here, but it was hiding just out of reach, beneath a thin, stubborn quilt of dust. Think of it like trying to find treasure with a plastic spoon. You scrape the surface, turn up dust, and declare the chest empty. Meanwhile, the real prize lies centimetres deeper, laughing at your efforts. This was the cruel irony of Chandrayaan-3. It hadn't failed. It had simply been too shallow, too blind. Its delicate laser spectrometers, its tiny scoop, they were toys against a world that demanded drills, claws, and patience. The discovery reframed the question entirely. It was no longer, does the moon have water? The evidence was mounting that yes, it does. The better question was, how deep do we need to dig to get it? And that changed everything. Because depth is not just a scientific curiosity, it's an engineering problem. A few centimetres deeper might mean an entirely new class of landers, stronger drills, heavier payloads, more expensive missions. The moon, once again, was dangling the answer just out of reach, daring us to try harder. But there was hope hidden in that frustration. If water was only centimetres, or maybe meters, beneath the surface, then it wasn't an impossible dream. It wasn't locked away in inaccessible caverns. It was there, waiting. All humanity needed was sharper tools and a little more stubbornness, and if history has proven anything, it's that our species has plenty of both. Why all this obsession with lunar water? Why spend decades smashing probes, mapping shadows, and sending rovers to freeze in the dark, just for a few molecules of H2O? Because water isn't just water. On the moon, it's survival. First, the obvious, astronauts need to drink. Every litre that doesn't have to be hauled from Earth saves staggering amounts of money. To launch a single bottle of water into space costs more than vintage champagne. Multiply that by the needs of an entire crew, and you're talking about payloads worth their weight in gold. But water does far more than quench thirst. It's also coolant for equipment, hygiene for astronauts, even a shield against radiation. Without it, a moon base would be a coffin sealed in dust. And here's the real jackpot. Water can be split. Break it apart into hydrogen and oxygen, and you've got rocket fuel. Not metaphorically, literally. That's the same propellant mix used by many of our most powerful engines. If you can mine lunar ice and turn it into fuel, the moon becomes more than a destination. It becomes a gas station for the solar system. Imagine this. Instead of launching giant rockets from Earth stuffed with fuel, you launch leaner, lighter ships. They stop at the moon, refuel, and continue to Mars, asteroids, or even further. Every kilogram of propellant you don't have to drag out of Earth's gravity well is a victory. And the moon, with only 1/6 of Earth's gravity, is the perfect pit stop. So when scientists talk about lunar water, they're not fantasizing about puddles or snowball fights. They're imagining a future where those frozen molecules are the cornerstone of an entire off-world economy. Water isn't just life. On the moon, water is power. If lunar water can be harvested in large enough quantities, it becomes more than just a life support system. It becomes the very fuel that propels humanity outward. Here's why. Water isn't just H2O. It's hydrogen and oxygen, the perfect partners for rocketry. Split the molecule apart with electrolysis, and you get liquid oxygen and liquid hydrogen, the same propellant mix that powered the mighty Saturn V rockets to the moon half a century ago. Picture it. Astronauts scooping icy regolith, melting it down, and feeding it into machines that strip it into its atomic halves. Out of the pipes comes oxygen for astronauts to breathe, and hydrogen to ignite engines. Suddenly, the moon is no longer just a pit stop. It's a full-service fueling station. The implications are staggering. Every mission that launches from Earth today has to carry all its fuel from the start, like a car driving cross-country with every gas tank it will ever need strapped to the roof. Inefficient, heavy, expensive. But if spacecraft could top up on the moon, the economics of spaceflight change overnight. Even better, launching from the moon is cheap. Its gravity is just 1/6 of Earth's. No thick atmosphere to push through, no crushing escape velocity. A rocket leaving the moon could be smaller, lighter, and cheaper, yet travel farther. That means missions to Mars, to asteroids, even to Jupiter's icy moons, suddenly become not dreams, but logistics. The moon transforms from a destination into a gateway, and all of it, every ambitious blueprint, rests on a deceptively simple question. How much water is really up there? Because if the moon's vaults are rich, then our future among the stars is a matter of engineering. But if they're poor, then the dream collapses back into dust. Water on the moon isn't just about drinking and fueling rockets, it's about building a sustainable foothold for humanity in space. Think of a lunar base. Astronauts aren't going to live in tents forever. They'll need habitats, greenhouses, recycling systems, and all of that hinges on one thing: closed loops. Nothing wasted, everything reused. Water is the cornerstone of that cycle. With enough of it, astronauts can create life support systems where waste is broken down, purified, and fed back into the loop. A sip of water today becomes the steam of tomorrow, the coolant of next week, and, after a little filtering, the drinking glass of next month. On Earth, it sounds unappetizing. On the moon, it sounds like survival. Then there's food. Lunar regolith, that grey powder, is lousy soil. But under controlled conditions, hydroponics, sealed domes, precise nutrients, plants can grow. What they can't grow without is water. A steady supply means astronauts might one day harvest fresh vegetables under alien skies, instead of squeezing paste from tubes. And water has another role: shielding. Cosmic rays and solar storms batter the moon without mercy. Thick walls of lunar soil can help, but water itself is one of the best natural insulators against radiation. Tanks of it built into habitat walls could double as both storage and protection. So when we talk about lunar water, we're not talking about novelty. We're talking about a material as versatile as steel or concrete, a resource that can build, protect, sustain, and expand human life off Earth. No water, no base. With water, the moon becomes not just a pit stop, but a home. By now you'd think the case was closed. We've smashed craters, flown orbiters, landed rovers, sniffed plumes and split spectrums. Surely we should know exactly how much water the moon has, right? Wrong. The maddening truth is that even after decades of searching, we're still left with contradictions. One mission says hydrogen is everywhere. Another finds nothing. One probe detects water molecules dancing in sunlight. A rover digs and comes up dry. We see signals in orbit, but they vanish on the ground. It's like trying to solve a puzzle where every piece changes shape the moment you place it. Take those eternally shadowed craters, cold enough to freeze nitrogen, perfect vaults for ice, and yet when we zoom in with our sharpest cameras, we don't see gleaming sheets of frost, just more darkness, more dust, or those daytime hydration signals, strong at dawn, gone by noon, back at dusk. Are they water molecules leaping in and out of existence? Or are we misreading the fingerprints, confusing them for something else locked in the soil? Every discovery feels like the moon is dangling a key in front of us, then swapping it for another lock. The result? We don't have a clear path forward. We know the moon has water, but how much, where it is, and how easy it is to reach, those remain questions with no straight answers. And yet, maybe that's the point. The moon is teaching us the most frustrating lesson in science. Certainty is a luxury we rarely get. The only way forward is to keep asking, keep digging, keep building sharper tools. The moon's mystery isn't solved. It's alive, and it keeps pulling us back, daring us to try again. The moon has been a riddle wrapped in dust for as long as we've looked at it. For centuries, poets called it lifeless. For decades, textbooks stamped it dry. Even when evidence piled up, we dismissed it as noise, contamination, wishful thinking. And yet, here we are, after probes, crashes, rovers, and decades of stubborn curiosity, finally convinced that water does exist there. The irony, we still don't know how much. It might be a thin veil clinging to soil grains, disappearing in the heat of noon. It might be patches of buried ice, hiding just beneath the surface quilt. Or it might be deeper vaults, ancient cometary cargo frozen solid for billions of years. But certainty isn't really the prize. The prize is what comes next. Because with every hint, every plume of vapour, every whisper of hydrogen, the moon is telling us something. Dig deeper. Come closer. Don't stop. The answer isn't in orbit, it isn't in theories. It's beneath the dust, waiting for the right drill, the right mission, the right stubbornness. And when we finally pull that water into the light, it won't just be a scientific triumph. It will be the cornerstone of a new era. A moon where astronauts drink from local wells. A moon where rocket tanks fill before leaping outward. A moon where domes rise from the regolith. Greenhouses bloom, and humanity's reach extends beyond Earth for the first time in history. That frozen soil isn't just science, it's destiny. So perhaps the greatest discovery isn't that the moon has water. It's that the moon is no longer just a story of where we've been. It's the prologue to where we're going.